In this video, I will discuss a two-tailed hypothesis test. For this hypothesis test, we're going to test about the mean when the population standard deviation is unknown. If the population deviation is unknown, we will use the sample standard deviation, denoted by the letter S. If this is the case, you would now use a t-distribution to test the null hypothesis about the mean. When using the t-distribution, you must assume the population you are sampling from follows a normal distribution. All other steps, concepts, and conclusions are the same. So, since we have a population standard deviation unknown, we'll use the t-test, and the calculation for the test statistic is x bar, which is your sample mean, minus the population mean, all over standard deviation divided by the square root of your sample size. So let's look at an example. The mean cost of a hotel room in New York is said to be $168 per night. To determine if this is true, a random sample of 25 hotels is taken and resulted in a mean of $172.50 and a standard deviation of $15.40. We're going to test this at a significance level, denoted by alpha, at the 0.05 level. So first, let's set up our hypothesis. Our null hypothesis, is that the mean price is $168. But we don't know if this is true. We don't know if it's higher or if it's lower. So I'm going to test this and say that it's not equal to $168. So when I do this, I'm going to show you how to do it by hand using tables. I will also show you how to do it with StatCrunch, and I will also show you how to do it with my template, my Excel template. So since we're testing at an 0.05 significance level, and this is a two-tailed test, we need to divide this alpha by 2 because now we have rejection regions and both of the tails. So when we divide by 2, we get 0.025. So that's the area to the right and to the left. As you can see, I have the rejection region over here to the right, the rejection region over here to the left. Everything in the middle is the do not reject, the null hypothesis. So we have to figure out the t-values that correspond to this area. And we are going to use a t-table. With this t-table, and this is in your textbook, this t-table is a little different from your z-table. In the z-table that we did with normal distribution, in the body of the table, it gave you the probabilities. In this case, in the body of the table, it gives you the t-values. The t-values separate the rejection region from the non-rejection region. So in order to use this table, you have to know your degrees of freedom as well as the area in the upper tail, as you can see by this picture. Degrees of freedom is denoted by DFs, and it's n minus 1, your sample size minus 1. And you look for that going down this column. And then the area in the upper tail, you look for here. And then where your degrees of freedom and the area meet up in the body of the table will give you your t-value. Okay. So going back to my problem, we know we took a sample size of 25. So my degrees of freedom will be 25 minus 1, which is 24. So now I need to figure out the t-value that corresponds to a degrees of freedom of 24 and the area in the tail 0.025. So one will be negative, one will be positive. So you're going to get the same number, you're just going to make one negative. So let's go ahead and look at the table. We know we have a degrees of freedom of 24, and we know that the area in the tail is 0.025. So let's see where these meet up. Meet up right here. So my t-value is 2.0639. Okay, so these two values, I made one negative, the other one is positive, separates the rejection region and the non-rejection region. So the next step will be to figure out my t-statistic. Once I figure out my t-statistic, I need to see where does it fall on this graph. Does it fall in the rejection region or the non-rejection region? So let's go ahead and write out the information that we have. We know that the sample mean is 172.50 and the sample standard deviation is $15.40. I'm going to use that information to calculate my t-statistic. The t-statistic is x bar minus mu all over sample standard deviation divided by the sample size, square root of the sample size. So when I plug my numbers back in and do the calculation, I get a t-stat of 1.46. If you look at this graph, 1.46 falls in the non-rejection region. I have it right here. Okay? So what does that mean? That means we do not reject the null hypothesis. So we don't have enough information to say that the true mean cost of hotels is different from $168. I don't have enough evidence to support the alternative hypothesis. Another way you can do this is with p-values. You're going to compare the p-value with your alpha level or your significance level. If the p-value is less than alpha, you reject the null. If it's greater than or equal to alpha, you do not reject the null. So there's a saying, if p is low, the null must go. So that means if your p-value is less than your alpha, the null must go. That means you must reject the null. If p is high, the null must fly. So if the p-value is greater than your alpha, you do not reject the null hypothesis. So I'm going to show you how to calculate the p-value. And actually, I'm going to show you how to do this whole test on StatCrunch. StatCrunch and my Excel templates will give you your p-values. So let's go ahead and do this in StatCrunch. So with StatCrunch, you're going to go to Stat. You're going to go to T-Stat because this is the t-statistic. We're going to do one sample with summary. We have summary data. So let's go ahead and plug in our information. Our sample mean was 172.5. Our standard deviation was 15.4. And we had a sample size of 25. The next part is where you do your tests. And the first one we're going to put in the mean, and once you put in the mean, it populates into for the second part. So you only have to type it in once. This box here, your null hypothesis, sorry, your alternative hypothesis, you can change. You can change it to greater than, less than. Actually, it's not working for me. Let me close it out and see if I can do it again. Right now, we're only doing we're doing two tails, but you're able to change that box to, still not working, but anyway, I'm not going to worry about it right now because I'm not doing those type of tests right now. So, but if you click on this, you're able to change it to less than or greater, less than or greater than, depending on the test. But since it's a two-tail test, we only have to worry about the not equal to symbol, and that's what we have here. So we're going to hit compute, and we get our information. As you can see, it calculated the t-statistic is 1.46. And it also gives you this p-value, which is 0.157. So if we go back, we got 0.157. This is greater than our level of significance, 0.05. So if the p is high, the null must fly. So do not reject. To me, I usually, when I do hypothesis tests, I just usually look at the p-value. I don't really get into the t-statistic and the critical values. You know, I don't look at the tables. I just go straight to the p-value. So you do not reject the null. This is just a quick way of doing it. And that's the same conclusion that we got here. Do not reject. If you want to use my Excel template, you're going to have to type in the information that you see in the highlighted in the blue boxes. So we're going to have to type in our X bar, our standard deviation, our sample size, and then we have to type in the actual test. We were testing 168. So you're going to have to type it in both of these boxes. Now with my template, if you click on the alternative hypothesis, you're able to change the test. So like I said, we're doing a two-tailed test. So we already have it set to not equal to, but you can do a less than, which is a one-tail, or you can do a greater than, which is also a one-tailed test. Where we're doing a not equal to. So this is a two-tailed test. And you also have to type in your level of significance. Your level of significance may not always be 0.05. It can be 0.1. It can be 0.01. Those are the most common. So with my template, I take it a little bit further. I show you the test statistic. As you can see, it populated is 1.46. That's what we got when we did it by hand. I also give you your critical values, which is 2.064. If you go back to the problem, my template calculated the critical values for you. So you don't even have to look it up in the table. I mean, you can if you want to do it by hand, but my Excel template gives you the critical values as well as the test statistic. It also gives you the p-value. And the p-value here is 0.156974, which you can just round to 0.157. And I take it a step further. I actually give you the answer. So it says, since 0.157 is greater than your level of significance, 0.05, we failed to reject the null hypothesis, which is what that's the conclusion we came to when we did it by hand. We do not reject the null hypothesis. Okay, so you have two options on doing these types of problems. You can do it by hand, you can use StatCrunch, or you can use Excel. So let's go ahead and do one more problem. Suppose a standard fertilizer has been shown to cause a species of plants to grow by an average of 10 inches. However, one botanist believes the new fertilizer causes this species of plants to grow by an average amount different than 10 inches. So this is going to be a two-tailed test. He doesn't say it's more than 10 inches. He doesn't say it's less than 10 inches. He just says it's different than 10 inches. So we don't know what direction these plants are growing. Are they going more or less? So we're going to say it's just different. So to test this claim, she applies the new fertilizer to a simple random sample of 15 plants and obtains the following information. So the sample size is 15. Her plants grew on an average of 11.4 inches, and the sample standard deviation is 2.5. So we're going to set up the hypothesis. This is how you do it by hand. So I'm not going to go step by step on how to do it by hand. I went over this before, so I'm giving you the basics. So we're testing that the mean is equal to 10. The alternative is not equal to 10. We know the sample size is 15. Degrees of freedom will be 14. Okay? So you're going to look in your table to figure out what are the t-values that cut off the non-rejection region from the rejection region. And since this is 14, your degrees of freedom is 14, and you got the upper tail of 0.025. Let's go ahead. We got this here and this here. So it meets up right here, 2.1448. So that's how I got these numbers here. Okay, so the next thing we have to do is calculate our t-stat. The t-stat is x bar, which is 11.4, minus the mean, which is 10, all over the standard deviation, which is 2.5, divided by the square root of the sample size, which is 15. So when I did all that, I got 2.168. Okay, 2.168, if I look at my graph, it falls in the rejection region. So what do we conclude? That means we reject the null hypothesis, and we have enough evidence to support the claim that the new fertilizer causes an average growth that is different than 10 inches. Okay? All right, so let's go ahead and do this in StatCrunch, and I'm going to do it with the p-value approach. So once again, I go to Stat, T-Stat, one sample with summary. They said the sample mean is 11.4. The sample standard deviation is 2.5, and the sample size is 15. And we're testing, it was 10. Okay, and we want not equal to. Okay, if I hit compute, as you can see, it gives me my t-stat, which is 2.168. That's what we calculated by hand. And we get a p-value of 0.0478. Okay, this is less than the level of significance. So the p is low, the null must go. The p is low, the null must go. So we reject the null hypothesis. Okay, that's the same conclusion when we did it by hand. So let's go ahead and do it with my template. The X bar is 11.4, standard deviation 2.5, sample size 15, and we said that this is 10 here, 10 here, we want not equal to. We're testing at a level of significance of 0.05. As you can see, what populates, we got 2.168 as the test statistic. I also gave you the critical value, which is negative plus or minus 2.145. Is that what we had before? Yes, that's what we got here. My critical values in these right here. I'll circle them. We got those. I got the test statistic of 2.168. And I got a p-value of 0.0478. Same thing that we got when we did it with StatCrunch. And what does my answer say? It says that my p-value is less than 0.05. We reject the null hypothesis. Just like I did when we did it by hand. Everything lines up. Okay, that's the end of this lecture.